Envision a cosmic sphere packed with hundreds of thousands of stars, moving as one ancient swarm in orbit around a galaxy. This exploration will guide you through globular clusters, formations so old they may contain the answers to the universe's earliest mysteries. We will delve into the secrets these stellar globes protect and discover what they can tell us about the hidden origins of our own Milky Way, embarking on a voyage to the forgotten heart of the cosmos, where each star is a relic of a bygone era. To help you visualize this, think of a garden filled with vibrant, luminous flowers, where every bloom is a single star, and the garden itself is a globular cluster. This is no ordinary garden, of course. It drifts through the immense void, suspended in the cosmic darkness. Globular clusters are collections of stars that have stayed gravitationally linked for billions of years, making them distinct and special. They serve as stellar time capsules, providing a precious window into the conditions of the nascent universe. These are not mere arbitrary collections of stars. They possess a distinct spherical structure and are overwhelmingly composed of ancient stars that have completed long evolutionary journeys. Astronomers view them as invaluable relics from the era of galaxy formation, true cosmic treasures. Examining their makeup and dynamics allows us to decode the secrets of how stars are born and how galaxies evolve. When you look at a globular cluster, you are quite literally peering into the distant past, as their stars are among the most ancient objects known. The significance of globular clusters goes far beyond their breathtaking appearance or immense age. They are fundamental to our comprehension of the universe's overall structure. For instance, did you know they are key to understanding dark matter? By tracking their movements and spatial distribution, scientists can deduce the existence of this elusive substance, which, while invisible, exerts a powerful gravitational pull that shapes galaxies. These clusters function as natural laboratories for observing astrophysical phenomena, making each one a readable chapter in the universe's grand story. Beyond the realm of astronomy, globular clusters have also captured the human imagination for centuries, inspiring poets, artists, and thinkers alike. Their profound beauty and enigma have woven them into our culture and mythology, where they stand for both the majesty of the cosmos and our own search for purpose within it. As technology has progressed, our fascination with them has surged. Powerful new telescopes and sophisticated techniques now allow us to gather data that deepens our understanding of these celestial marvels. Ultimately, globular clusters compel you to consider your own place in the grand scheme of the cosmos. They serve as a reminder that even though we may feel insignificant against the universe's sheer scale, we are all part of its ongoing narrative. So, the next time you gaze up at the night sky, realize you might be seeing more than just stars. You could be witnessing the echo of a remote past, held within a globular cluster. Are you prepared to venture further into these celestial enigmas? Globular clusters are truly captivating stellar assemblies, appearing like brilliant jewels adrift in the cosmic darkness. To define them simply, a globular cluster is a tightly packed, ancient gathering of stars that orbits a galaxy's core. Picture a sphere brimming with shimmering lights, each one a star held in place by gravity, forming a magnificent display that narrates the story of the universe itself.
These clusters have a very recognizable form, much like a compact round golf ball, but composed of thousands or even millions of stars instead of rubber. The density within them is extraordinary, with stars situated far closer to one another than is typical elsewhere in the cosmos. If you've ever imagined what life inside such a cluster would be like, it would be a realm of perpetual light and motion, with every star contributing its own radiance to a celestial ballet, choreographed by the unwavering pull of gravity.
Among the most compelling characteristics of globular clusters is their immense age. A great number of them are thought to be more than 10 billion years old, which places their origin remarkably close to the beginning of the universe. Just consider that for a moment. These stars have endured for eons, observing the development of entire galaxies and the birth of subsequent stellar generations. Each cluster stands as a venerable sage of the cosmos, a silent guardian of secrets from the universe's most distant past. When we examine their composition, we find that globular clusters consist almost entirely of old stars and are notably deficient in heavy elements. In contrast to the stars in our own galaxy, which possess a wide array of more complex elements, these clusters are predominantly composed of simple hydrogen and helium. The crucial question, then, is why this distinction matters so much. Understanding globular clusters is crucial because they provide insight into how the very first stars came into being and how the cosmos gradually became infused with new elements through events like supernova explosions. You might assume that all globular clusters are fundamentally alike, but that couldn't be further from the truth. While they do share common characteristics, an incredible amount of diversity exists among them. Some are extraordinarily dense, whereas others are more spread out, a difference that stems from their individual histories and interactions with their galactic surroundings, making each one a miniature cosmos with its own story of evolution. More than just beautiful celestial objects, globular clusters are fundamental to deciphering the structure of galaxies. If you picture galaxies as vast cities, then these clusters are their most ancient, traditional districts. By examining them, astronomers can uncover vital clues about the formation and development of galaxies over cosmic timescales. These stellar collections are typically located in the outer parts of galaxies, within the halo that envelops the main galactic disk, which strongly suggests they were among the earliest systems of stars to form. As our knowledge of globular clusters deepens, we find they serve as true natural laboratories. Within these dense environments, scientists can observe stellar dynamics and the intricate ways stars influence one another. For example, you can witness stars moving at incredibly high velocities, which enhances our comprehension of gravity and the formation of cosmic structures. Have you ever considered how stars can even form in such a crowded space? In a globular cluster, it's possible for stars to merge or even siphon material from each other, leading to some truly remarkable astronomical events. At the heart of many globular clusters lies a captivating enigma: black holes. The presence of these immense dark objects raises profound questions about the formation and life cycle of the clusters themselves. Some researchers propose that the constant interactions between stars in such a dense region could actually contribute to the birth of massive black holes. This suggests that globular clusters are not merely homes for stars, but potentially the very places where some of the universe's most cryptic black holes originate. Our ability to observe these distant star systems is a direct result of incredible technological progress. Modern telescopes and space-based observatories have given astronomers the tools to study globular clusters with an unprecedented level of detail. Through the images and data we gather, we can explore the intricate structure and chemical makeup of these fascinating stellar groups. Can you fathom the excitement of capturing light from a star that has journeyed across space for billions of years to reach us? Ultimately, globular clusters represent something far more significant than simple groupings of stars. They are cosmic artifacts that provide a direct look into the universe's distant past. With every new observation and study, we inch closer to solving the great mysteries of the cosmos. Through this journey of exploration, you are not just investigating outer space, but also delving into our own origins and our place within this immense universe. Globular clusters are indeed captivating cosmic structures, but have you ever thought about their journey of discovery throughout human history? To appreciate their story, you need to travel back in time. In the earliest days of astronomy, imagine ancient observers looking up at the night sky with only their eyes. Without the aid of telescopes, the vast cosmos was an unsolved puzzle, and some of its secrets appeared as nothing more than faint, clustered points of light. The earliest records of what we now know as globular clusters appeared centuries ago. The 18th century British astronomer Charles Messier was among the first to systematically note them. This dedicated cataloger of celestial objects was unknowingly making history when he recorded a globular cluster in the Hercules constellation, classifying it simply as a nebulous, fuzzy patch. This was a pivotal first step, but at the time, no one could have guessed that these smudges were actually swarms containing thousands of individual stars. With the invention and refinement of the telescope, the study of globular clusters entered an exciting new phase. Objects that were once blurry patches in the sky began to resolve into their true, magnificent forms. During the late 19th century, the German astronomer Wilhelm von Struve carried out more detailed examinations, starting to unravel the real nature of these clusters and revealing a complexity that was previously unimaginable. You can only imagine the thrill he must have experienced upon seeing these stars sparkling together in such a compact formation. As we moved into the 20th century, technological innovation continued to revolutionize our perspective. Armed with more powerful telescopes and advanced photographic methods, astronomers could analyze not just the shape and brightness of globular clusters, but also their stellar composition. They discovered that these clusters were overwhelmingly composed of very old stars, effectively opening a window into the universe's early history. What ancient secrets, you might wonder, were locked within these primeval suns? Each cluster became a cosmic time capsule, a relic from the birth of our own galaxy. Breakthroughs in astrophysics were also instrumental in shaping our modern understanding of globular clusters. The creation of theoretical models and the use of computer simulations allowed scientists to piece together how these systems form and evolve. It became clear that these were not random assortments of stars, but gravitationally bound families that shared a common origin, much like a group of old friends connected by a single formative event from their past. Yet, even with centuries of investigation, the story of globular clusters is still filled with unanswered questions that continue to fascinate researchers, such as why some clusters grow to be so much more massive than others, and what specific factors dictate their formation and ultimate fate. These enduring questions fuel astronomical inquiry, pushing researchers to employ ever more sophisticated telescopes and engage in global collaborations to unravel the enigma of globular clusters. Observing these celestial objects has fundamentally shifted our understanding of the cosmos, transforming what were once mere specks of light into portals to the cosmic dawn. You can think of each cluster as a kind of stellar archive, packed with data on the galaxy's own history. And it is truly remarkable to realize that when you gaze upon these formations, you are peering back through time to the era when the very first stars ignited. The relationship between these stellar collections and the development of galaxies has emerged as a particularly captivating field of research. As scientists have delved into the past of these clusters, they have realized these are not just static relics. They actively participate in the dynamics of their galactic homes. Understanding their gravitational interplay with other celestial bodies is crucial for comprehending the formation and long-term evolution of galaxies themselves. With the dawn of the 21st century, research into globular clusters has entered a new era of discovery. Groundbreaking space missions and powerful next-generation telescopes are delivering images and data of unprecedented clarity. These technological leaps have unveiled incredible details about the chemical makeup, distribution, and movement of the stars within these clusters, inching us closer to resolving the many puzzles these formations present. In many respects, the story of globular clusters mirrors the story of human exploration itself, with each generation of scientists building upon the work of those who came before them. It serves as a powerful reminder that while astronomy can appear highly technical, its core is driven by an insatiable curiosity. When you look up at these ancient star systems, you are doing more than just observing distant suns. You are engaging with the grand narrative of the cosmos and humanity's timeless quest for meaning. The investigation into globular clusters is far from over. This field will undoubtedly continue to advance as long as humanity persists in its drive to explore, question, and uncover new knowledge. These stellar collections remind us that every star contains untold stories and deep secrets just waiting to be deciphered. You can picture globular clusters as immense cosmic libraries, filled with ancient stars that hold the keys to understanding the birth of our galaxies. But how did these enigmatic objects come to be? To find the answer, you must embark on a journey through cosmic time, where the primary ingredient is interstellar matter. Consider the universe as a grand cosmic factory where interstellar gas and dust serve as the fundamental building blocks for creating new celestial structures. Under the right circumstances, vast clouds of this material start to contract due to their own gravity, much like how a pile of sand compacts when you press down on it. As the matter draws closer together, particle collisions generate immense heat. Ultimately, the internal temperature and pressure escalate to a point where nuclear fusion ignites, marking the birth of new stars. So what becomes of these stars that are all born from the same cosmic nursery? For globular clusters, the newly formed stars do not disperse. Instead, they stay gravitationally linked, creating a tight-knit stellar community. Within this dense and active environment, you can witness a host of captivating phenomena, from stars merging to form more massive, brilliant counterparts, to others being flung out toward the cluster's edge on a solitary voyage through the cosmos. Perhaps the most compelling characteristic of globular clusters is their immense age. The majority of these systems originated billions of years ago, not long after the Big Bang itself. This makes them unique laboratories, containing some of the oldest stars you can possibly observe, providing direct insight into the chemical makeup of the primordial universe and the very conditions that gave rise to galaxies. It is important to recognize that not all globular clusters are identical. They exhibit a great deal of variety, with some being incredibly dense while others are far more spread out. This diversity stems from factors like the initial mass of the parent gas cloud and the specific environmental conditions present during their creation. Each cluster possesses a unique origin story, and by studying these variations, you help piece together a more comprehensive narrative of cosmic evolution. Metallicity is a crucial factor in the development of globular clusters. In astronomical terms, metals are defined as any element heavier than hydrogen and helium. The universe's first stars were made almost exclusively of these two light elements, but as they aged and died, they forged heavier elements that were then dispersed into space. The concentration of these metals within a gas cloud directly impacts its star-forming potential, thereby shaping the characteristics of the resulting cluster. The passage of eons is another vital component in the life of a globular cluster. Over vast timescales, gravitational interactions among the member stars can dramatically alter the cluster's overall structure, with some stars merging or exploding as supernovae, and others being ejected entirely. This continuous cycle of stellar life and death drives the cluster's evolution, making these objects perfect natural laboratories for you to study a wide range of astrophysical processes. By observing the way stars congregate and travel within these clusters, for instance, scientists can gain insights into gravitational dynamics and the workings of gravity on immense scales. This understanding extends beyond astronomy, offering applications that help us comprehend other intricate systems, from the climate of our planet to the formation of other solar systems. Moreover, globular clusters serve as reflections of the universe's past. By analyzing the light from their stars, astronomers can ascertain their chemical makeup and, in turn, deduce the conditions of the interstellar medium from which they emerged. This knowledge is crucial for grasping not only the evolution of the clusters themselves, but also the assembly of galaxies and the entire development of the cosmos. The formation of globular clusters is truly an incredible process, born from the interplay of matter, gravity, and time. These stellar collections are direct witnesses to the universe's long history, and studying them provides us with invaluable clues about how our own galaxy came to be and has changed over eons. As we learn how they are born and evolve, we can start to tackle fundamental questions about the origin and ultimate destiny of our own corner of the vast cosmos. Globular clusters are like tiny islands of stars adrift in the immense ocean of space. But where exactly can you find them? The answer to that is quite fascinating. Typically, you will find these clusters situated in the outlying regions of galaxies, as if they were guardians of the cosmos's oldest secrets. Their placement isn't arbitrary. It is directly connected to the history and evolution of the galaxies they inhabit. When you look at a galaxy, globular clusters are often arranged in a spherical halo around the main galactic body, resembling brilliant gems on a cosmic necklace. This halo stretches far beyond the galactic disk, which is the most dense and active region of the galaxy. This distribution gives us vital clues about how galaxies are formed and how they behave over long stretches of time, with the clusters acting as stellar fossils that help us understand the environment in which they grew. The location of globular clusters is also intrinsically linked to gravity. Because they are so dense and compact, these clusters possess a powerful gravitational field that allows them to firmly hold their stars together. Despite the vastness of the surrounding space, you can picture each star in the cluster as a drop of water in a sphere. Gravity acts as the container, keeping all the drops bound together and preventing their escape. If you examine things more closely, you'll discover that different galaxies host a varying number of globular clusters. For example, older elliptical galaxies tend to have a great many, whereas spiral galaxies like our own Milky Way have fewer, which raises a compelling question. Why are some galaxies so much richer in globular clusters than others? The answer likely resides in their unique histories and how they've interacted with other star systems over billions of years. Additionally, globular clusters are not isolated phenomena in the cosmos. You will often observe them in the company of other galactic features, such as stellar disks and massive clouds of gas. These clusters can influence the motion of stars in their vicinity, functioning almost like small centers of gravity that subtly alter the trajectory of passing objects. Observing this interplay helps us understand how galaxies form and evolve as integrated systems. When you scan the heavens, you're likely to see globular clusters at various stages of their life cycles. Some might even be in the midst of colliding with other structures, triggering a commingling of stars and gas that reminds us the universe is in a perpetual state of flux, with globular clusters being an active part of this dynamic cosmic dance. An especially compelling aspect of the distribution of globular clusters is their connection to dark matter. Although we cannot observe dark matter directly, its gravitational effects are unmistakable. Globular clusters seem to be arranged in a pattern that strongly implies the presence of this mysterious substance, almost as if they form a map pointing to where it might be concentrated. This connection offers a valuable clue about the composition of the universe and the behavior of matter on the largest scales. You must also remember that globular clusters are fundamental to our perception of cosmic time. By studying their positions and distribution, astronomers can draw conclusions about the history of the galaxy that contains them. This makes you wonder what secrets these stellar arrangements might still hold about the universe's distant past. Each globular cluster could be seen as an ancient chronicle, filled with stories about the formation of the earliest stars and galaxies. However, their existence is not static. Over vast timescales, globular clusters can be influenced by external forces, such as the gravitational pull from other galaxies or direct collisions with other clusters. These dynamics can spark the birth of new stars while leading to the destruction of others, forcing us to constantly rethink our understanding of galactic evolution. As we observe these clusters, we might also contemplate their role in the future of the cosmos. As galaxies continue to change, it seems probable that some of these clusters will eventually merge, creating even more intricate and massive structures. This possibility invites you to imagine a future where globular clusters become even more diverse and varied than they are today. Ultimately, when reflecting on the distribution of globular clusters, it's crucial to remember that each one is a portal to the universe's past. They are living witnesses to cosmic history, and their study allows us to connect the dots between the present and a time long ago. So, when you gaze up at the starry sky, you are seeing not just points of light, but the echo of ancient eras still resonating through the immense expanse of space. Just how ancient are globular clusters, and what makes their age so captivating? To truly appreciate this, you first need to envision time as an immense line, upon which these clusters represent some of the very oldest markers we are capable of finding. These celestial formations act as cosmic time capsules, giving you a window into the universe in its infancy. Many of them are incredibly old, with some reaching ages of up to 13 billion years. Given that the universe is roughly 13.8 billion years old, you can think of these clusters as stellar elders who have silently observed the entire span of galactic history, offering insights into the cosmos just after the Big Bang. By studying these star groups, astronomers gain a clearer understanding of stellar evolution. The key lies in their consistent chemical makeup. Most stars within them are abundant in helium, but lack significant amounts of heavier elements. This composition tells you that they formed during an epoch when the universe had not yet forged the diverse array of elements we see today, providing invaluable clues about the conditions of their birth. The immense age of globular clusters also prompts compelling questions regarding the formation of galaxies. As some of the very first structures to emerge, they help us decipher how galaxies came together in the early cosmos. Each cluster fits into the grand scheme like a piece of a puzzle, contributing to a more complete picture of our galactic past and the creation of the massive structures you see today. Furthermore, the age of these clusters serves as a tool for investigating the expansion of the universe itself. By observing their distribution and motion, astronomers can deduce the rate at which the cosmos is expanding. It is as if every cluster is transmitting information about its long journey through space, helping us unravel the mysteries of how the universe behaves on the largest scales and potentially revealing its ultimate fate. Research into globular clusters also extends into the realm of dark matter. This enigmatic substance, thought to constitute the bulk of matter in the universe, has proven incredibly difficult to detect directly. Because they are so ancient and gravitationally stable, these clusters provide natural laboratories where scientists can hunt for indirect evidence of dark matter, potentially leading to future breakthroughs. An interesting puzzle is why the ages of globular clusters vary. The explanation may lie in the specific environments where they were born. Clusters that formed in more densely packed cosmic regions seem to be older, whereas those from more sparsely populated areas are often younger. This suggests the early universe had distinct neighborhoods, each developing at its own unique pace, a diversity from which you can learn a great deal. These stellar collections offer an invaluable resource for chronicling cosmic history. By analyzing the ages of individual stars within a cluster, astronomers can pinpoint when the cluster itself came into being, creating a timeline for the development of entire galaxies. In this way, these ancient objects reveal a profound connection between space and time, showing you how certain structures can endure and tell remarkable stories even as the universe evolves. As our exploration continues, globular clusters are proving to be essential tools for understanding not just cosmic history, but its future as well. They provide critical insights into the processes of new star formation and the ongoing evolution of galaxies, and it is exciting to consider what other secrets will be revealed as we continue down this path of discovery. Ultimately, you must acknowledge the profound importance of these ancient clusters in our search for knowledge. Their age and composition reveal so much about the universe's past, and their continued study is fundamental to answering questions that still perplex us. Each one is like a historical volume waiting to be read, filled with narratives of the past and lessons for the future, beckoning you to discover what else these cosmic witnesses have to share. Globular clusters appear as vast congregations of stars, seemingly gathered into a single cosmic community. But what kinds of stars actually populate these groupings, and what makes them so extraordinary? To find the answer, you must delve into their unique properties and see how they contrast with stars found elsewhere in the universe. Let us begin by considering the age of the stars within these clusters. The majority are ancient, with many exceeding 10 billion years in age. If you can picture a wise elder who has seen countless eons pass, that is what these stars represent. Their immense longevity makes them genuine cosmic fossils, capable of recounting the story of our own galaxy's formation and the birth of the universe itself. Interestingly, despite their great age, a large number of stars in globular clusters belong to spectral type G, the same as our own Sun. Yet alongside them you find a surprising variety of stars in different evolutionary phases. Some have become red giants, having swelled their outer layers and undergone profound changes, while others are now white dwarfs, the dense remnants that mark the final life stage for sun-like stars. Have you ever considered what these stars experience, growing old in such a crowded and fiercely competitive place? The density inside a globular cluster is simply astonishing. Try to envision a reality where thousands of celestial bodies are crammed into an incredibly confined volume. This extreme proximity gives rise to some truly compelling gravitational dynamics, where stars can draw so near that one might even siphon material from its companion, creating an enthralling cosmic performance. The diverse palette of colors you can observe in these clusters is equally breathtaking, revealing a story about their inhabitants. You'll notice that the younger stars tend to radiate with blue light, whereas their more ancient counterparts glow in shades of yellow or red. This spectrum of colors acts as a kind of stellar rainbow, providing us with vital clues about the unique history of every single star. Understanding these chromatic differences is key to unlocking their secrets. Stars within globular clusters also provide a perfect natural laboratory for researching stellar evolution. Because they all came into existence at roughly the same time and from the same cosmic nursery, astronomers are able to compare their various traits, This comparison allows for a deeper comprehension of how stars develop under a range of conditions, offering lessons from a stellar community that shares a singular origin and destiny. These gravitational forces don't just shape individual stars. They can also set the stage for truly spectacular events. There are instances when stars within these clusters merge, resulting in a supernova. Such an explosion is a magnificent cosmic firework, unleashing a tremendous burst of energy and seeding the surrounding space with heavy elements. You have to wonder about the profound impact these cataclysmic events have on their galactic neighborhood. Furthermore, these clusters can become homes for neutron stars and black holes, which are the compact leftovers from earlier supernovae. These incredibly dense objects are like the last remnants of a stellar celebration, where only the most massive members remain. It raises the question of how these powerful remnants influence the equilibrium of the cluster and the behavior of the stars that orbit nearby. Investigating the stars in globular clusters also offers insights into the chemical makeup of the cosmos. As stars reach the end of their lives and explode, they disperse elements into the void that are fundamental for creating new stars and planets. In this way, these stellar gatherings function as a type of cosmic manufacturing plant, forging the very elements that have sculpted our universe. The intricate motion of stars inside a globular cluster is an endlessly fascinating subject. Gravitational tugs and pulls can lead to some stars being flung out of the cluster entirely, while others are inexorably drawn toward its dense center. This constant and varied movement creates a perpetual celestial ballet, directly affecting the lives of the stars and the long-term evolution of the cluster itself. Often, the most luminous stars within a globular cluster become the primary targets for astronomers hoping to decipher the structure and history of the universe. By closely examining these bright beacons, we can begin to unravel mysteries related to the formation of galaxies and the distribution of matter. If only these stellar giants could speak, imagine the tales they could tell. The relationship between the stars in a globular cluster and their immediate galactic environment is another compelling area of study. As these clusters journey and evolve, they can actually influence the birth of new stars in their vicinity. This process is reminiscent of a wise teacher whose experience helps to shape the path of younger students, creating a cycle of cosmic creation and destruction. As our investigation into the stars of globular clusters deepens, we must acknowledge the transformative impact of modern technology. Powerful new telescopes and observatories permit us to view these clusters with a level of detail that was previously unimaginable. This technological leap has already led to incredible discoveries about the nature and behavior of stars, leaving us to anticipate what new secrets will be unveiled in the future. Finally, the sheer variety of stars within these clusters cannot be overlooked. Every star possesses its own unique narrative, and by studying them collectively, we gain a much more comprehensive view of how the universe operates. Just as each individual has a personal history, every star in the cluster adds its own experience to the grand cosmic saga, prompting us to wonder what other marvels are waiting to be found. Within this immense universe, where stars appear to be locked in an eternal choreography, globular clusters travel like troops of dancers, each moving to its own rhythm, yet maintaining perfect harmony. These stellar assemblies are not mere static collections, but are dynamic systems that narrate stories of their interactions, their movements, and their evolution through the ages. Although often pictured as simple gatherings of old stars, the reality is far more exhilarating. Inside these clusters, stars are woven together in a delicate gravitational equilibrium, a crucial balance where each star's pull on the others creates a web of forces that preserves the cluster's structure. Over vast stretches of time, however, this stability can falter, leading to dramatic changes. When that occurs, the stars start to move with greater freedom, and some may even be cast out from the cluster entirely, much like guests at a party who decide to wander off and explore the world outside. The velocities at which these stars travel are truly mind-boggling, with some reaching speeds of hundreds of kilometers per second. To give you some context, think about being in a car traveling at 100 kilometers per hour. You can feel the speed. Now, try to imagine moving at more than double that velocity, surrounded by countless others doing the same. This is what life is like inside a globular cluster, a constant, intense, and sometimes chaotic rush where stars not only move swiftly, but also engage with one another in complex ways. These close encounters between stars in a globular cluster can result in the formation of binary systems. What exactly does that entail? Picture two close friends who make a pact to always travel together, sharing their journey and resources as they navigate through the cosmos. This is essentially what happens when two stars become gravitationally bound, creating a new dynamic within the bustling stellar city. The stars within these cosmic arrangements are bound by gravity, orbiting a mutual center of mass. With the passage of time, such systems can lose their stability, sometimes resulting in magnificent explosions like supernovae, when one of the stars runs out of fuel. This dynamic process influences not just the stars themselves, but also transforms the chemical composition of the entire cluster. But this cosmic story has even more layers. As the most massive stars conclude their life cycles, they often leave behind dense remnants like neutron stars or black holes. Consider what this means for their companions within the cluster. It's much like an orchestra having to instantly adapt after its conductor departs the stage. The surviving stars must renegotiate their orbital paths, a process that can trigger profound shifts in the cluster's overall structure. Globular clusters are far more than just breathtaking sights. They serve as natural laboratories where we can observe the laws of physics in real time. By analyzing their movements and evolution, astronomers are able to put theories about gravity, stellar dynamics, and even dark matter to the test. It's truly incredible to realize that by observing these stellar collections, you are seeing a direct reflection of the fundamental forces that shape our universe. Furthermore, the very distribution of globular clusters throughout galaxies provides deep insights. You typically find them in the galactic halo, a vast region enveloping the main body of a galaxy, which strongly suggests they formed during the earliest epochs of galactic creation. You can think of globular clusters as ancient fossils from the universe's past, preserving a record of how things were in primordial times. Over billions of years, the evolution of a globular cluster is a complex, non-linear journey. These stellar cities can undergo mergers and interactions with one another, or even become involved in the birth of new galaxies. These cosmic events are similar to the way a river's course can change, where separate currents merge into a single, powerful flow that forges an entirely new ecosystem. The dynamics of globular clusters are much the same, with movement and interaction giving rise to new structures and behaviors. Investigating the dynamics of globular clusters also deepens our comprehension of how galaxies themselves are formed and structured. Through the observation of these moving star groups, astronomers can piece together the evolutionary past of the galaxies they inhabit. Each globular cluster acts as an open book, filled with clues about the birth and development of its parent galaxy. This context naturally leads to a compelling question. What future awaits globular clusters in the grand scheme of the cosmos? As the universe continues its relentless expansion and evolution, these clusters will also persist in their motion and transformation. Some are destined to merge, while others will gradually disperse their stars into the void. This celestial dance is nowhere near its finale. In truth, we might just be witnessing the opening acts of an epic saga. Ultimately, it's important to see globular clusters as something more profound than mere collections of stars. They are silent witnesses to the passage of eons, guardians of cosmic secrets, and the central figures in a dynamic drama that is constantly unfolding. Every single interaction and movement they make provides us with a glimpse into both the past and the future of the cosmos. So, the next time you gaze up at the night sky and spot a globular cluster, know that you are observing a dance that has been performed for billions of years, a cosmic ballet that connects every one of us to the vast and enigmatic universe we call home. What could globular clusters and black holes possibly have in common? This question has captivated astronomers for decades. Picture a colossal vortex in space, where stars are gathered in a gravitational embrace so powerful that nothing can break free. This is the essence of a globular cluster, an assembly of thousands or even millions of stars that have existed together for billions of years. Yet, hidden within the hearts of some of these clusters are even deeper cosmic enigmas. The link between globular clusters and black holes is utterly fascinating. On one side, you have black holes, which are cosmic behemoths capable of swallowing light itself. On the other, you have globular clusters, which appear to be the ideal setting for these mysterious objects to reside. But how do these connections actually form? Some researchers propose that during the universe's infancy, globular clusters provided the perfect conditions for black holes to emerge. With the passage of time, certain stars within these clusters burn through their fuel, collapse under their own gravity, and transform into black holes, turning the cluster into a fertile ground where black holes can multiply. Imagine a garden where seeds sprout into plants, and then, unexpectedly, some of those plants grow into colossal trees. But the story doesn't end there. Some globular clusters seem to harbor a supermassive black hole right at their core. This implies that as stars orbit this central black hole, they can be gradually pulled toward it, setting the stage for an awe-inspiring celestial performance. As a result, the interplay between stars and black holes becomes a gravitational ballet that unfolds over billions of years. A question astronomers often contemplate is whether a single globular cluster can be a home to multiple black holes. The answer appears to be yes. Computer simulations indicate that within certain clusters, two black holes can interact, eventually merging to form an even more massive entity. It's like watching two dancing pairs combine to create a single, more spectacular performance. So, what part do black holes play in the life of a globular cluster? A black hole can function like a powerful magnet, attracting stars in its vicinity. This attraction can alter the cluster's internal dynamics, causing a significant redistribution of its stellar population. Picture a group of friends at a gathering. If one person begins to dance with great energy, they might draw others toward them, fundamentally changing the event's atmosphere. In certain instances, globular clusters containing black holes shine more brightly than those without them. This phenomenon occurs because as stars are pulled into a black hole, they unleash tremendous amounts of energy as radiation. This process causes the entire cluster to illuminate, as if in celebration of a grand cosmic festival. Research into these cosmic events has intensified in recent years, as modern telescopes and advanced observational techniques have enabled astronomers to pinpoint specific globular clusters that host black holes. This marks a significant advance in our understanding of the universe, even though many questions still await answers. For instance, Have you ever considered how black holes inside globular clusters might shape the development of the galaxies they inhabit? It's hypothesized that these celestial objects can affect the birth of new stars and even alter the entire galaxy's dynamics, almost like a conductor guiding the tempo of a vast cosmic orchestra. Furthermore, by investigating the relationship between globular clusters and black holes, we can uncover clues about dark matter. This mysterious substance, which we cannot see, appears to be fundamental to the structure of the cosmos. By studying the behavior of these clusters and black holes, scientists can deduce the influence dark matter has on their interactions. The link between globular clusters and black holes is, in truth, an intricate puzzle we are just beginning to assemble. As our technology improves and our observational instruments become more sophisticated, we draw ever closer to understanding the reality. Each new discovery serves as another piece of the puzzle, helping us form a clearer picture of the immense universe we call home. So, the next time you gaze up at the night sky, take a moment to think about those star-packed globular clusters, which may conceal black holes deep within them. It serves as a potent reminder that beyond what is visible, the universe is teeming with mysteries and marvels waiting to be found. The brilliant stars you see are merely the surface of a deep ocean of cosmic complexity that beckons us to explore further. What is the great enigma that connects globular clusters to dark matter? To grasp this, you first need to picture the universe as an immense ocean, teeming with stars, planets, and countless other celestial bodies. Within this cosmic sea are globular clusters, dense archipelagos of ancient stars. Meanwhile, dark matter represents the unseen depths of this ocean, a substance we can't perceive directly but whose gravitational pull affects everything around it. Globular clusters are composed of thousands, sometimes millions of stars, all held together in a tight gravitational embrace. Over the course of their long lives, they have managed to preserve their distinct shape and structure, which has enabled them to withstand the influence of the surrounding dark matter. Yet, the question remains, what part does dark matter actually play in how they form and evolve? The solution could tell us a great deal about the history of our universe. Dark matter is a form of matter that emits no light or energy, which makes it practically undetectable with our current telescopes. Scientists, however, have confirmed its existence through the gravitational effects it has on visible matter. Imagine you're at a park, observing a group of people playing catch. Even if you couldn't see the person throwing the ball, you could infer their location and strength just by watching the ball's path. In much the same way, astronomers can map the presence of dark matter by observing the motion of stars within globular clusters. One of the most compelling questions revolves around how dark matter shapes the initial formation of these clusters. It is widely believed that dark matter was instrumental in creating the very first structures in the cosmos. In its infancy, the universe was a turbulent environment filled with slight variations in density. Dark matter, being far more plentiful than regular matter, provided a kind of cosmic scaffolding that gravitationally attracted normal matter, helping to assemble the earliest galaxies and globular clusters. Even as these clusters formed and matured, dark matter's influence on their internal dynamics continued. But how, precisely? Dark matter establishes a gravitational well that dictates the movement of the stars inside the clusters. Much like a troupe of dancers moving in sync with the music, the stars within a globular cluster follow orbits shaped by the gravitational field of the surrounding dark matter. Without this constant pull, the clusters would likely break apart and lose their defining characteristics over time. There are several competing theories regarding the distribution of dark matter in relation to globular clusters. Some research indicates that these clusters might reside in areas with a high concentration of dark matter, whereas other models suggest it might be spread more uniformly. This ambiguity is what makes the study of globular clusters and their connection to dark matter such a dynamic and exciting field of scientific inquiry. A fascinating method for investigating this involves the detailed study of globular clusters in galaxies near our own. Using advanced telescopes, scientists can meticulously examine these clusters. By tracking their movements and mapping their distribution, they can gain valuable insights into the quantity and location of dark matter within these galaxies, which is a bit like discovering a secret family recipe by observing how all the ingredients are combined. Understanding the link between globular clusters and dark matter also enhances our knowledge of how large-scale structures form in the universe. For example, observing how these clusters group together and are distributed can offer clues about the assembly of vast galactic superstructures. The process is similar to piecing together a family tree, where every branch tells a unique tale of growth and development. An additional layer of complexity in the relationship between globular clusters and dark matter involves black holes. Certain studies propose that these clusters may host supermassive black holes in their cores. Like dark matter, these black holes are invisible, but their presence can be detected through their powerful gravitational effects on the stars orbiting them closely. As astronomers delve deeper into these cosmic connections, more questions inevitably surface. How do the interactions between dark matter and globular clusters impact the formation of new stars? Could these ancient clusters hold the key to understanding the mystery of dark matter's behavior? Each answer we find only opens the door to new lines of inquiry, cementing this as one of the most captivating areas of modern astronomy. In the end, the relationship between globular clusters and dark matter is a territory filled with fascination and surprise. And as our understanding grows, we learn not just about the clusters themselves, but about the very fabric of our universe. Although you cannot see it, dark matter is a critical component in the narrative of the stars, which in turn makes it a part of our own story as observers of the cosmos. As we press forward with our explorations, every new finding brings us a step closer to solving the universe's greatest riddles and understanding our own place within it. It's impossible to know what revelations await us in the quest to comprehend dark matter and its intricate connection to globular clusters. Observing globular clusters within the vastness of the universe can feel like admiring the brilliant gems on a royal crown. So, how do we get a closer look at these captivating formations? The key is found in the advanced technologies we've engineered for space exploration. Telescopes, those colossal instruments that scan the heavens, are among the primary tools you and I rely on to examine these spectacular stellar gatherings. Optical telescopes function as immense eyes, gathering the faint light from distant stars. While these instruments have been around for centuries, their recent technological evolution is nothing short of breathtaking. Picture yourself using a telescope on a high mountain peak, far from the glare of city lights. The pristine sky lets you not only see globular clusters, but also make out details that reveal the story of their creation and development. But what about the light that remains invisible to our eyes? This is where radio and infrared telescopes enter the picture. Our vision is limited to a narrow slice of the electromagnetic spectrum, but these instruments enable us to investigate longer wavelengths we cannot perceive. By viewing a globular cluster with a radio telescope, for instance, we can map the activity of gas and dust around the stars, uncovering secrets that would otherwise stay concealed. Satellites are also indispensable for observing globular clusters. Space-based observatories, most famously the Hubble Space Telescope, give us a vantage point completely free from the distortion of Earth's atmosphere. Imagine having a perfectly clear line of sight, where the starlight can be seen in its full, unobscured splendor. These missions have delivered astonishingly detailed images, allowing us to appreciate features we could never have seen from the ground.
After we collect these observations, what happens to all the information? Every image and light spectrum presents a puzzle that requires careful solving. Astronomers employ sophisticated analytical techniques to decode the chemical composition of the stars inside globular clusters. By examining the light they radiate, we can determine what they're made of, their age, and their evolutionary path, which helps us understand their role in the wider universe. In our current technological age, artificial intelligence has emerged as an exceptionally valuable tool for poring over astronomical data. Algorithms possess the power to process immense volumes of information with speed and precision, identifying subtle patterns that a human eye might easily overlook. This capability is bringing us closer to answering questions that once seemed entirely out of reach. International collaboration stands as another pillar of modern astronomy. Researchers from all over the globe openly share their findings and unite on joint projects to study globular clusters. This synergy results in an incredible accumulation of data, greatly enhancing our collective knowledge of the cosmos. Each new discovery serves as another piece in the grand puzzle of cosmic history. So, the next time you cast your eyes toward the night sky, take a moment to consider all the work that goes into studying these distant star systems. It is the fusion of advanced telescopes, powerful satellites, artificial intelligence, and global teamwork that grants us this unprecedented access to the universe. Each of these components fits together, revealing the profound beauty and complexity of the cosmos. What does the future hold for the observation of globular clusters? With every new technological breakthrough, the possibilities expand almost infinitely. New telescopes and ambitious missions are already in development, promising to probe the universe's mysteries on an even deeper level. Space exploration is a journey without an end, and each discovery brings us closer to grasping our own place in the grand scheme of things. It is vital to remember that every star within these clusters has a unique story to tell. From its birth to its eventual demise, each one serves as a witness to the universe's long evolution. By studying them, you not only gain a better understanding of these celestial objects, but also connect with our own origins as a species. This work is a testament to human curiosity and our relentless drive to explore the unknown. Globular clusters are not exclusive to our own galaxy. They are found in abundance throughout other galaxies, and each one offers a unique perspective on the formation and history of the universe. Studying these external clusters allows astronomers to appreciate the incredible diversity of these objects, showing how different galaxies host their own unique collections of ancient stars. A truly captivating aspect is how dramatically globular clusters in other galaxies can differ in their size and density. Some are so densely packed they resemble a solid sphere of starlight, while others are far more spread out, as if their stars are performing a slow cosmic ballet. This variety forces us to ask compelling new questions about what factors drive these differences and how a galaxy's own history shapes the clusters it forms. Have you ever considered that globular clusters are like cosmic fossils that tell us the story of the universe? These collections of stars, which formed during the earliest phases of the cosmos, are essential for grasping not only the evolution of galaxies, but also the behavior of the universe in its entirety. You might be wondering what this has to do with cosmology. I invite you to join me on this stellar exploration, where we will investigate the fascinating link between globular clusters and our understanding of the cosmos itself. Let's begin by addressing a compelling question.
What makes astronomers view globular clusters as cosmic laboratories? The explanation is rooted in their immense age and unique composition. As some of the most ancient objects in existence, having formed over 11 billion years ago, these clusters give us a rare glimpse into the distant past. Studying them allows scientists to piece together what the universe was like in its infancy, long before the galaxies we recognize today had taken shape. Think of every star within a globular cluster as a distinct witness in a grand cosmic trial. Each one carries its own testimony about the conditions of its formation and its subsequent evolution through time. This, however, brings up another question. How can all these separate accounts help us comprehend the broader narrative of the universe? The answer to that puzzle is found in their chemistry.
Some globular clusters are located millions of light-years from Earth, dwelling in distant galaxies like Andromeda and others throughout the local group. Attempting to conceptualize these enormous distances is a staggering exercise, much like trying to imagine the number of road trips required to reach them. This sheer remoteness presents a considerable challenge for scientists, but thanks to technological breakthroughs like advanced space telescopes, we can now capture light from these far-flung objects and uncover their secrets.
Within the framework of galactic formation, it is fascinating to see how globular clusters serve as stellar fossils. They are relics from the universe's earliest epochs of star creation, offering us invaluable clues about the initial conditions of the cosmos. By examining these ancient fossils across a range of galactic environments, astronomers can painstakingly reconstruct the history of the universe itself. Comparisons between globular clusters in different galaxies can also provide insights into the nature of dark matter. Observations indicate that clusters within more massive galaxies tend to have a greater concentration of this elusive substance. This suggests a potential connection between a cluster's structure and the way this mysterious material is distributed, raising the question of whether globular clusters could help us understand not just visible matter, but the matter we cannot see as well. Furthermore, the interplay between globular clusters and other galactic components paints a more complete picture of their universal role. For instance, the location of a cluster, whether in the galactic halo or nearer to the core, significantly influences its evolutionary path and the ultimate destiny of its constituent stars. This prompts us to ask how the gravitational pull of a host galaxy shapes the entire life cycle of these dense star systems. Many globular clusters are also populated by stars that are substantially older than those in galactic disks, which means that when you observe these systems in other galaxies, you are doing more than just looking at stars. You are peering deep into cosmic time. Each individual star holds its own unique history, enabling us to trace how the universe has transformed over billions of years. Clusters in other galaxies can also host a variety of unusual phenomena, such as variable stars or even binary systems, where two stars orbit a common center. These systems offer clues about how stars evolve under entirely different circumstances. Every new discovery prompts further questions, like how these stars behave in alien environments, and what they can teach us about the chemistry and physics of their host galaxy. As astronomers persist in their search for globular clusters beyond our own galaxy, they simultaneously employ computer simulations to model their expected appearance. These sophisticated models help predict the distribution and dynamics of clusters under a wide array of conditions. By juxtaposing these simulations with actual observations, scientists can validate their theories and continuously refine their understanding in a productive dialogue between data and modeling. Technology is a driving force in this entire process, with modern instruments like the James Webb Space Telescope opening up new frontiers for exploration. Its powerful infrared capabilities allow us to penetrate the clouds of dust and gas that so often veil these captivating objects from view. The secrets that this new generation of technology will unlock about globular clusters are something we can only begin to imagine. Moreover, the study of these clusters extends beyond just their structure and composition. There is a growing fascination with how they might influence the creation of new stars in their immediate vicinity. In certain galaxies, observations suggest that globular clusters can serve as catalysts for star formation by supplying the raw materials necessary for stellar birth. Could it be that these ancient assemblies of stars are directly responsible for sparking new life in their galactic homes? Each new piece of information we gather about globular clusters in other galaxies brings us one step closer to solving the grand puzzle of the universe. Their history is a rich saga of interaction, evolution, and relentless discovery. By looking beyond the Milky Way, we come to realize that every cluster contributes a unique story that is woven into the larger narrative of cosmic formation, reminding us that we are all connected through the shared history of the cosmos. The stars packed into these globular clusters possess a remarkably similar chemical makeup, which strongly suggests they all originated from the same place at the same point in history. This unique characteristic gives astronomers a way to investigate the conditions of the primitive universe, much like reading the pages of an ancient cosmic chronicle. The link between globular clusters and cosmology grows even more compelling when you examine their arrangement in space. These stellar collections are not scattered randomly. Their placement around galaxies, particularly in the outer halos, reveals crucial details about how those galaxies grew and evolved. By studying the distribution of globular clusters, scientists can piece together the story of a galaxy's formation and its past interactions with its cosmic surroundings, effectively making them markers of the universe's grand architecture. So, why is the study of dark matter so critical when it comes to globular clusters? You can think of a cluster as a kind of treasure map, with dark matter being the buried prize. These regions of space are far denser in dark matter than others, which means exploring them can provide vital clues about the nature of this elusive substance that constitutes the vast majority of the universe's mass. Grasping how dark matter influences globular clusters could truly transform our entire understanding of physics and the cosmos. Now, let's consider the expansion of the universe. Have you ever thought about how globular clusters are connected to this fundamental cosmic process? By analyzing the most ancient stars within these clusters, astronomers can actually measure the rate at which the universe is expanding. This turns these star groupings into powerful instruments, not just for gauging the speed of cosmic expansion, but for achieving a clearer picture of its history and its ultimate fate. It's also fascinating to see how our methods for studying globular clusters have evolved. In the past, astronomers were limited to observing them with the unaided eye, or very basic telescopes. Today, remarkable technological leaps allow us to use powerful space telescopes and high-resolution observatories to analyze the light they emit, unveiling details about their composition and structure that were once completely hidden from view, and enriching our knowledge of their formation. Here's another captivating question. What can globular clusters teach you about the birth of new stars? Although they are predominantly made up of ancient stars, investigating them offers valuable insights into the entire stellar life cycle. By understanding the intricate interactions between stars within these dense clusters, astronomers can learn more about the star formation processes that take place in other, younger regions of the universe. The relationship between globular clusters and black holes is another area of intense interest. Some of these clusters harbor massive black holes at their cores, which raises profound questions about how such immense objects can form and evolve within such a crowded stellar environment. The dynamic interplay between the cluster and its central black hole could hold the key to understanding galactic evolution and the broader role that black holes play in shaping the cosmos. As our investigation of globular clusters deepens, new and more complex questions continually emerge. How might our theories about the universe shift as we uncover more about these ancient star systems? Every fresh discovery holds the potential to challenge our established truths and open entirely new avenues for scientific inquiry, positioning these clusters not just as objects of study, but as powerful catalysts for new ideas. The future of research into globular clusters appears incredibly promising. With even more advanced telescopes on the horizon and new space missions in development, our capacity to observe and analyze these mesmerizing objects will only improve. This progress could pave the way for discoveries that completely reshape our view of cosmology and the very origins of the universe itself. In the end, globular clusters represent far more than simple collections of stars. They serve as witnesses to the distant past, keys to unlocking the present, and guides to the future of our cosmos. Through the careful study of their history, composition, and dynamics, scientists can continue to unravel cosmic mysteries and perhaps find answers to some of the most fundamental questions about our existence. So, the next time you gaze up at the night sky, consider that each faint sparkle might be an echo from the dawn of the universe, patiently waiting to be heard. The bond between globular clusters and star formation is both profound and intricate. These immense gatherings of stars are not just a breathtaking sight. They function as genuine cosmic laboratories where you can observe the processes of stellar creation in action. To understand how stars are born in these ancient stellar communities, it's essential to delve into the very distinct environment that globular clusters provide. First, it is crucial to recognize that globular clusters are primarily composed of extremely old stars, many of which came into being when the universe was much younger. This fact implies that the conditions under which these stars were forged were vastly different from those we see in modern star-forming nebulae. By offering a glimpse into this early era, globular clusters serve as a unique window into the past, bringing us closer to the very beginnings of star formation. When astronomers look at a globular cluster, they are essentially viewing a family of stars that were all born at roughly the same time from a single, vast cloud of gas and dust. This primordial cloud, made of hydrogen, helium, and small amounts of other elements, began to fragment and collapse under its own gravity. Throughout this process, the densest pockets within the cloud were compressed until they ignited, becoming the stars we see today. But what makes this process so unique within globular clusters? A key factor is the sheer density of the environment, which allows gravity to operate with extraordinary efficiency. Picture a crowd of people pushing against one another in a small room. Each shove is likely to move someone closer to the center. This same principle governs the matter collapsing to create stars in a globular cluster, where the intense gravitational forces can significantly accelerate the rate of star formation. Though not all stars created in this process end up being identical. Some of these stars evolve into massive bodies that, at the conclusion of their life cycles, can detonate as supernovae, while others mature into smaller, more enduring stars. This variety in star formation gives rise to a dynamic environment that allows for the study of different phases of stellar development. The synthesis of elements deep within the cores of these stars is another point of great interest. Throughout their existence, stars in globular clusters generate heavier elements by means of nuclear fusion. When they erupt as supernovae, they disperse these elements throughout space, enriching the interstellar medium and facilitating a continuous cycle of stellar birth and death that is essential for the creation of new stars and planets. So, what becomes of the stars in a globular cluster that avoid such a violent end? Many of them transition into white dwarfs, the dense remnants of stars that have depleted their nuclear fuel. Although these white dwarfs lack the brilliance of their younger siblings, they still contribute to the cluster's overall mass and can gravitationally influence other stellar bodies. The interactions among these stars are also incredibly compelling. In such a densely packed setting, stars can approach one another closely enough to swap material or even coalesce. This process not only triggers the formation of new stars, but can also result in unusual stellar arrangements, like binary systems or neutron stars. So, how do astronomers investigate these phenomena in globular clusters with the aid of powerful telescopes and sophisticated observational techniques? Scientists are able to dissect the light that these stars emit. Since every star possesses a distinct signature in its light spectrum, researchers can determine its chemical makeup, age, and temperature, which helps in understanding the history of both the individual star and the entire cluster. As our exploration of globular clusters deepens, their significance in the process of star formation becomes increasingly clear. These stellar groupings function as natural laboratories, where we can witness star formation in progress, uncovering cosmic secrets that might otherwise stay concealed. You can think of each globular cluster as an ancient manuscript that chronicles the story of star formation across the cosmos. When you contemplate the link between globular clusters and star formation, it's evident that these ancient assemblies are more than just collections of stars. They are fundamental components in the grand cosmic puzzle. Studying them not only reveals how stars are born, but also provides insights into the evolution of galaxies and the history of the universe itself. In essence, globular clusters serve as time capsules, enabling us to journey through the history of star formation. By examining these groups, astronomers not only solve mysteries from the distant past, but also build a foundation for comprehending the universe's future. How can a relatively small congregation of stars shape the evolution of an entire galaxy? These spherical collections of ancient stars, known as globular clusters, hold a pivotal role in the vast theater of the cosmos. Let's consider them the matriarchs of the galaxy, carrying stories and secrets that have been handed down through billions of years. Their very presence not only informs us about the past, but also helps us grasp how galaxies expand and transform over eons. The relationship between globular clusters and the evolution of galaxies is both profound and fascinating, as they act like time capsules that hold information about the initial phases of our galaxy's creation. Since they are among the most ancient objects in the universe, studying them provides clues about how galaxies, our own included, have developed since their earliest days. What secrets do these venerable star clusters conceal? Each one is a microcosm, a small stellar society that has withstood the ravages of cosmic time. By observing these groupings, astronomers can piece together the processes that have molded galaxies. For instance, globular clusters can affect the distribution of surrounding gas and dust through their gravitational pull, which in turn impacts the birth of new stars. Imagine a grand ball where stars are the dancers moving in coordinated groups. Globular clusters are like those seasoned dance partners who, over countless years, have perfected their movements together, and their gravitational influence can alter the tempo of the stars around them, helping to orchestrate the emergence of new stellar generations. Have you ever considered how such a compact assembly can wield such a significant influence? Globular clusters also function as natural laboratories. By analyzing the chemical makeup of their stars, astronomers can deduce the conditions of the environment where they originally formed. This information is critical because the chemistry of the primordial gas and dust dictates the characteristics of the stars born from it, thereby illuminating the history of galactic chemistry. As galaxies mature, globular clusters can be gravitationally captured by other galaxies, a process that can set off dramatic cosmic events. When two of these clusters interact, it results in a cosmic ballet that may lead to the creation of new stars, or even the complete dissolution of the clusters involved. You can compare this interplay of gravitational forces to two rivers converging, their waters mixing to create entirely new currents. The narrative of galactic evolution is deeply connected to the history of globular clusters. These stellar groups stand as witnesses to monumental cosmic occurrences, such as galactic mergers or the formation of supermassive black holes. Studying them allows us to chart the history of the universe, unveiling the pivotal stages that led to the stellar systems we observe today. The dynamic between globular clusters and the remainder of the galaxy is also crucial for understanding the galactic halo, the diffuse region of dark matter and gas that envelops a galaxy. Situated within this halo, globular clusters help us map the distribution of matter in the universe. It makes you wonder what mysteries about dark matter we might unlock by studying them. The cosmos is not always a place of perfect harmony. On occasion, globular clusters can be pulled apart, their stars stripped away by the gravitational influence of larger galaxies. This process, which astronomers call dispersion, demonstrates just how delicate these ancient stellar structures are on the immense canvas of the universe. Much like a close-knit circle of friends that drifts apart after relocating to a big city, these clusters can see their fundamental character erode over vast stretches of time. Looking at the bigger picture, the effect that globular clusters have on the development of galaxies brings up questions about the ultimate destiny of those galaxies. Can we expect these primordial collections of stars to survive into the far distant future? As the cosmic expansion continues, it's possible that globular clusters will become mere echoes of a bygone age, testaments to a time when stars burned with greater intensity. These clusters act as a vital connection between what was and what will be, allowing scientists to forecast our own galaxy's evolutionary path by studying their behavior and properties. Could you be seeing the very initial stages of how new galaxies and star clusters might form in the deep future? The evolution of a galaxy is more than a mere physical process. It unfolds as a story rich with spectacle and drama. With their profound history and crucial role in galactic dynamics, globular clusters are the central figures in this cosmic tale. By investigating them, you uncover not just their origins, but also the part they are destined to play in the universe's future. When you reflect on this, the existence of globular clusters serves as a powerful reminder that every single star has a narrative, and despite their immense distance, their impact is felt throughout the vastness of space. So, the next time you gaze into the night sky, you can appreciate not just the aesthetic beauty of the stars, but also the deep history they reveal about the cosmos and its ongoing development. The tale of globular clusters is a saga of endurance and change, one that urges us to keep exploring and learning as we gradually unlock the universe's secrets, one star cluster at a time. For millennia, even before we possessed telescopes powerful enough to resolve them, globular clusters have held a special fascination for humanity. Since the dawn of civilization, cultures worldwide have looked toward the heavens, seeking meaning and answers. Have you ever gazed at a dense patch of stars and felt it might contain the very secrets of existence? In numerous mythologies, these clusters were given diverse interpretations, often seen as divine entities, or as a sacred link between the earthly and celestial realms. But what is it about these stellar groupings that has so thoroughly captured the human imagination? In ancient Greece, for instance, globular clusters were believed to be the eyes of the gods, and early astronomers, despite their limited technology, could identify some of these luminous formations. They imagined them as gateways to the afterlife, where the spirits of legendary heroes would congregate. This deep-seated fascination with the sky is a recurring theme that connects countless cultures across history, from the Incas, who saw star clouds as homes for celestial beings, to Chinese culture, where the Pleiades cluster was a symbol of prosperity and abundance. Our comprehension of these astronomical objects grew in step with scientific progress. During the 17th century, Galileo Galilei became one of the first individuals to view globular clusters through a telescope, uncovering the true composition of these celestial marvels. It was then that the world understood these ethereal clouds were, in fact, tightly packed assemblies of individual stars, each with its own life cycle. Yet, this scientific revelation did not erase the ancient stories. Instead, it simply added a new, more profound layer to our collective understanding of them. Globular clusters have also made their mark on popular culture, frequently appearing in films and literature as potent symbols of mystery and the spirit of exploration. Who among us hasn't imagined journeying through one of these dense stellar fields, hoping to discover cosmic secrets hidden for eons? Science fiction often uses these breathtaking visuals to build narratives that whisk us away to strange, faraway worlds, tapping into our innate curiosity about our own place in the universe. These phenomena, once seen only through the prism of mythology, are now central to complex scientific inquiry. Modern astronomy views globular clusters as far more than just beautiful subjects of observation. They are critical tools for understanding the history of our galaxy and others. New modern scientific narratives have even begun to form around them, proposing they might hold keys to understanding cosmic mysteries like dark matter. Considering this journey from myth to science, it's evident that these stellar formations are a bridge connecting ancient wisdom to contemporary knowledge, reflecting our evolving beliefs and ambitions through the ages. As you look up at a clear night sky, you can feel a connection to something much larger than yourself, something that has been a source of wonder in myths and legends for all of human history. Isn't it extraordinary to consider that every star you see was once an object of profound admiration and deep contemplation for our ancestors? Globular clusters, therefore, are not merely astronomical occurrences. They stand as a testament to our species' unending quest for knowledge and a deeper understanding of the world around us. From the earliest civilizations to our current era of space exploration, the human drive to investigate the unknown has been a constant force. Every time you gaze at the night sky, you are sharing an experience with countless generations of dreamers, scientists, and storytellers who also looked up, searching for their own answers. In a world where science and mythology often appear to be in opposition, globular clusters offer a fascinating space where both can thrive, becoming symbols of our collective curiosity and our quest to find our place in this immense cosmos. As our exploration and knowledge expand, the narratives we weave around these stellar collections will also grow, enriching both our scientific understanding and our cultural heritage. Ultimately, you can view globular clusters as a beautiful metaphor for our own existence, a collection of individual stars, each with its own unique brilliance, all brought together in a harmonious cosmic dance. They serve as a powerful reminder that, much like the stars in a cluster, we are all fundamentally connected within the vast and enigmatic creation we call our home. The investigation of these stellar groupings is a thrilling area of study that consistently captures the interest of astronomers and scientists around the globe. But what exactly makes them so captivating? Think of a globular cluster as a cosmic archive, an ancient library where every star is a volume containing the history of the universe and its development. By delving into these clusters, astronomers are able to unlock secrets that not only illuminate the history of our own galaxy, but also shed light on the story of the cosmos itself. One of the most significant projects currently in progress centers on the globular cluster Omega Centauri, which has attracted considerable attention due to its unusual characteristics that set it apart from its peers. You can picture this as a complex puzzle, and Omega Centauri holds the key. Scientists are working intently to ascertain whether this cluster is, in fact, the remnant core of a dwarf galaxy that was long ago assimilated by our Milky Way, a discovery that could transform our understanding of how galaxies grow. Another powerful method involves leveraging next-generation observatories like the Hubble Space Telescope and the James Webb Space Telescope. These instruments function as extraordinary cosmic lenses, enabling us to see the universe in a level of detail that was previously unimaginable. With their capabilities, researchers are gathering extensive data on the age, chemical makeup, and dynamic behavior of globular clusters. Every new image they produce adds another chapter to the story of our universe, bringing us progressively closer to comprehending its immense age and origins. Have you ever considered that recent findings suggest globular clusters might hold a critical role in the ongoing search for dark matter? This mysterious substance, which remains invisible to us, accounts for the majority of the matter in the universe. Scientists are now observing how the gravitational pull of these clusters interacts with the surrounding dark matter. You can compare this to watching how a net moves through the water. By analyzing the dynamics of these interactions, we may uncover vital clues about the fundamental nature of this elusive material. As our technological capabilities advance, new initiatives are being developed to examine globular clusters located in other galaxies. With the forthcoming deployment of more powerful observatories, such as the Extremely Large Telescope, astronomers are eagerly anticipating the chance to explore these stellar systems in distant galaxies. This endeavor is comparable to charting a new continent on an ancient map, where each newly studied cluster could yield invaluable information about the diverse ways galaxies have formed and evolved across cosmic time. Furthermore, the data acquired from space missions like the Gaia satellite is fundamentally changing our grasp of the locations and compositions of globular clusters. Gaia operates as a kind of cosmic cartographer, meticulously mapping millions of stars, which in turn helps scientists piece together how these clusters are spread throughout our galaxy. This knowledge is indispensable for constructing a more accurate and detailed model of the Milky Way's formation and evolutionary path. Astrobiology has also begun to focus on globular clusters in its quest for answers about the origins of life. While these densely packed stellar environments are not considered the most probable locations for life to emerge, their study could provide clues about the conditions that facilitated life's development elsewhere in the universe. It's akin to studying an ancient civilization to better understand the rise of our own. By unlocking the secrets of these stars, we might just discover the essential ingredients for life on other worlds. These ancient star systems are also proving to be of great interest in the search for exoplanets. Although globular clusters are not the typical hunting grounds for habitable planets, investigating them can offer fresh perspectives on how planetary systems form and develop in such extreme settings. Astronomers are pioneering new techniques to detect planets in these unusual environments, a pursuit that could significantly broaden our understanding of planetary diversity across the cosmos. As these research efforts move forward, the significance of globular clusters in contemporary astronomy continues to grow. Each new finding not only contributes another piece to the vast puzzle of galactic evolution, but also provokes a host of new questions. This creates a perpetual cycle of curiosity and discovery, where every answer we find inevitably leads to more profound unknowns. Current projects are concentrating not just on observation, but also on sophisticated modeling, using advanced computational simulations to recreate the evolution of globular clusters over billions of years, much like directing a film where stars are the actors and the universe's history is the script. The future of globular cluster research appears exceptionally bright, with numerous ambitious projects and international collaborations already in motion. The convergence of various scientific disciplines, including physics, chemistry, and astronomy, continues to enrich this field by providing novel perspectives. This interdisciplinary cooperation is essential because the study of globular clusters teaches us not only about the stellar formations themselves, but also about the fundamental nature of the universe as a whole, highlighting their importance far beyond the confines of astronomy. Have you ever considered what part globular clusters play in our grand understanding of the universe? It's a compelling question that captivates both professional scientists and amateur astronomy lovers alike. These ancient star systems are more than just silent witnesses to cosmic history. They have been instrumental in driving major breakthroughs in modern astronomy. Their profound impact actually stems from their fundamental nature. Think of globular clusters as cosmic time capsules, holding stars that have been around for billions of years. By analyzing these primordial suns, astronomers can decode the secrets of how both stars and galaxies first came into being. Observing the various life stages of stars within a single cluster, for instance, offers scientists profound clues about the formation of the universe's very first stars, making these clusters invaluable astronomical fossils. When you consider their cosmological influence, these clusters have been pivotal in comprehending the distribution of matter across the cosmos. By measuring the gravitational pull from globular clusters, researchers can calculate the quantity of dark matter that envelops them. This makes these clusters unique natural laboratories for studying this unseen, mysterious substance, which constitutes the vast majority of the universe's mass. Furthermore, researching these systems has completely transformed our perspective on galactic evolution. Globular clusters don't simply orbit galaxies like our Milky Way, they actively shape their development. Through interactions with other stars and galactic formations, they can trigger new star birth, or even facilitate the merger of entire galaxies, offering vital insights into how galaxies expand and transform over time. Technology has been a crucial ally in deepening our study of globular clusters. Increasingly powerful instruments, such as the Hubble Space Telescope, give researchers the ability to see these stellar groupings with unparalleled clarity. This technological leap has led to the identification of new clusters and enabled meticulous examination of their properties, fundamentally altering our perception of a once dark universe. Beyond powerful telescopes, computer simulations offer another avenue for understanding the complex dynamics of globular clusters. By digitally recreating the conditions of the early cosmos, scientists can validate theories about their formation and evolution. This gives you a virtual cosmic laboratory where you can test the laws of physics in scenarios that are impossible to observe directly. The investigation into globular clusters is far from complete, as the future promises even more remarkable findings. An upcoming generation of advanced telescopes and space missions is poised to explore the enduring enigmas of dark matter and dark energy, two cosmic components about which we still know very little. The potential for discovery in globular cluster research is immense and continues to grow. Moreover, the technologies created specifically to investigate these clusters have spurred progress in unrelated disciplines like particle physics and engineering. This ripple effect of innovation shows how insights from one scientific field can trigger a cascade of discoveries in others. It is certain that globular clusters will remain a subject of intense focus within the scientific world. These celestial objects have even permeated popular culture, with their captivating beauty and mystery inspiring films, books, and documentaries. In doing so, they have motivated new generations to gaze at the night sky and contemplate our own position in the cosmos, influencing not just science but the collective human imagination. Ultimately, globular clusters are much more than mere collections of ancient stars. They serve as windows into the distant past, instruments for probing dark matter, and agents of galactic change. With every new technological breakthrough and each fresh discovery, we draw nearer to unraveling the universe's greatest puzzles, exploring this cosmic library, one volume at a time. As we continue to delve into their secrets, we find that every answer uncovered about globular clusters only gives rise to new, more profound questions. The search for knowledge is an unending journey, and these stellar beacons will keep illuminating the path for astronomers. Each star within a cluster is a reminder that in the grand design of the cosmos, there is always more to discover. First, it is essential for you to recognize that globular clusters are akin to cosmic time capsules, which hold preserved information from the earliest stages of galaxy formation. By examining their chemical makeup and movements, scientists are able to decode the secrets of our universe's creation. Just think about the possibility of looking directly into the distant past to uncover the truths it conceals. This is precisely the goal researchers have in mind when they study these ancient star systems. It is truly fascinating how modern technology is transforming our capacity to observe these clusters. We are on the cusp of a new age in astronomical research, thanks to the development of increasingly powerful telescopes and Earth-orbiting satellites. The information we gather now has the potential to completely reshape our comprehension of how globular clusters travel and change within their host galaxies. As our observational tools become more sophisticated, the questions we ask also grow more complex. What other revelations might be waiting for us within these primeval stellar groupings? One of the most compelling future topics is the relationship between globular clusters and dark matter. This baffling substance, which constitutes the vast majority of the universe's mass, continues to be a profound puzzle. Yet, globular clusters could offer indispensable clues, as their distribution and behavior might help us finally grasp how dark matter interacts with the visible matter around it. We could be on the verge of a discovery that fundamentally alters our view of the cosmos. Furthermore, globular clusters might provide new insights into the formation of black holes. It seems that some of these clusters harbor massive black holes at their cores, which prompts intriguing questions about the development and evolution of these cosmic giants. Through the study of globular cluster dynamics, astronomers are starting to chart the ways in which black holes influence their immediate environments. It is possible these investigations could redefine everything we know about gravity and the fabric of space-time. The coming decade promises to be a pivotal period for research into globular clusters. With the deployment of next-generation instruments like the James Webb Space Telescope, we are about to receive images and data of a quality never before seen. These technological leaps will not only enable us to observe globular clusters in faraway galaxies, but also give us the chance to compare and contrast various clusters throughout the universe, with each new finding serving as another piece in our model of the cosmos. Beyond this, scientists are increasingly treating globular clusters as cosmic laboratories, where stellar processes can be observed directly. You might wonder how stars are born in environments so radically different from those in our own galaxy, or what these systems can reveal about the initial conditions that triggered star formation in the first place. The solutions to these inquiries could very well revolutionize our understanding of astrophysics. Within the discipline of cosmology, globular clusters are taking on a central role in our quest to understand the origins and evolution of the universe. By observing their distribution and their interactions with other galactic structures, astronomers are assembling an ever-sharper picture of how galaxies were born and how they have transformed over cosmic time. You can think of each cluster as one more part of the vast cosmic puzzle that helps us piece together the history of everything. However, the future significance of globular clusters is not confined to academic pursuits alone, as they also influence our culture and how we perceive the cosmos. As our knowledge of these ancient star systems expands, their majesty and mystery could inspire new generations of astronomers, artists, and deep thinkers. It's not hard to imagine that a child looking up at the sky tonight might be motivated to become the next great explorer of the universe. Our comprehension of globular clusters is in a constant state of flux, and every new piece of information seems to generate more questions than it resolves. What mysteries do they continue to conceal from us? The curiosity that defines our species is limitless, and it is this very drive that compels us to gaze at the heavens in search of answers. Within every single globular cluster, there is a narrative waiting to be discovered, and as we advance, each revelation has the power to shift our perspective on the universe we call home. The next generation of astronomers will be the ones to carry this thrilling adventure forward. With the rise of artificial intelligence and advanced computer simulations, it will be possible to model and forecast the behavior of globular clusters in ways that were previously unimaginable. The question for us is, are we prepared to witness how these developments will reshape our cosmic understanding? In the end, the future of globular cluster research is incredibly bright and filled with promise. As we persist in our exploration, each cluster emerges as a crucial key for unlocking the universe's greatest secrets. Their story is one of discovery, curiosity, and profound wonder. So, the next time you find yourself looking up at the star-filled sky, remember that there is far more than what you can see, and that every point of light in the darkness may hold secrets we have yet to unveil. Globular clusters truly are the jewels of the cosmos. Across the journey we've taken together, we have explored their intricacy, their elegance, and their immense astronomical value. But what do they ultimately teach us about the universe? Why are they so critical to comprehending our own existence and the cosmos we are part of? Let's consider their extraordinary age. These star systems are among the oldest objects known, with lifespans exceeding 10 billion years. This means they were present for the birth and evolution of galaxies, long before our own solar system even formed. Imagine for a moment being an observer of the universe's entire history, like a wise elder who has seen everything unfold. Every star within a globular cluster is a living testament to that history, a relic from the formation of the first elements in the cosmos. It is nothing short of astounding to think that these stars have endured through eons and still shine today like beacons in an ocean of darkness. Their connection to galaxies is equally compelling, as they function like archives, preserving the vital records of galactic evolution. Investigating these stellar collections allows us to piece together the history of galactic evolution across eons. If these ancient swarms of stars could share their tales, They would reveal the profound cosmic secrets concealed within their densely packed hearts, offering a direct look into the universe's past. Naturally, this brings us to one of the greatest puzzles in cosmology: dark matter. The very formation and movement of globular clusters appear to be intertwined with this invisible substance that constitutes the majority of the universe's mass. By analyzing the arrangement of stars within them, scientists can infer the distribution of dark matter, potentially making these clusters the very keys needed to solve the riddle of the cosmos's true composition. Our ability to observe these formations has transformed our perception of the cosmos, as cutting-edge telescopes and advanced technologies grant us unprecedented access to these remote stellar cities. Using sophisticated instrumentation, astronomers can meticulously analyze the chemical makeup, age, and orbital dynamics of these clusters. It makes you wonder what extraordinary discoveries are just over the horizon. Beyond their scientific importance, these celestial gatherings have long captivated the human imagination, inspiring art, culture, and mythology. For centuries, they have stirred a sense of awe, with different traditions viewing them as gateways to other realms, or as symbols of the bridge between our world and the heavens. You have to consider how these ancient interpretations continue to shape your own sense of belonging in the vastness of space. When you consider the future, the potential influence of globular clusters on the field of astronomy is truly thrilling. Every new finding from these stellar relics moves us closer to comprehending not just the universe's grand narrative, but our own beginnings as well. It is fascinating to anticipate what revolutionary new ideas might spring from the continued observation of these ancient congregations of stars. The list of questions seems to grow infinitely longer, prompting us to ask how these clusters take shape in distant galaxies and whether there are others still hidden from our view. As you delve into these mysteries, it becomes clear that each solution only unveils a new set of puzzles, placing us in a perpetual and beautiful cycle of learning. The true significance of these clusters extends far beyond the light they emit, offering profound insights into the fundamental nature of matter, energy, and space-time itself. Within every stellar interaction lies a lesson on the cosmic scales of creation and destruction, serving as a powerful reminder that while you may feel insignificant against the backdrop of infinity, you are an integral part of something truly magnificent and enigmatic. As we draw this discussion to a close, it is worth taking a moment to consider what the study of globular clusters reveals about our own humanity. Perhaps their greatest lesson is that you, much like these ancient stars, are woven into an immense and intricate tapestry of existence. Every individual plays a part in the cosmic narrative, no matter how small that role might appear. Ultimately, globular clusters are not merely collections of suns. They are portals to cosmic history and signposts for our future explorations, constantly reminding us that the universe is brimming with secrets yet to be uncovered. So, the next time you gaze upward, recognize that each glimmer of light represents a narrative waiting to unfold. In this immense stellar ocean, we are all voyagers on a perpetual journey where new knowledge always awaits.